Our question today is, what are the 6 types of simple machines? All machines, no matter how complicated, can be broken down into 6 simple types of machines or combinations of those 6. Now, ancient people invented these simple machines to help them lift and move heavy objects. For example, the Great Pyramids. The ancient Egyptians used simple machines to lift these heavy objects up very, very high spots in order to place them on top of the other blocks to make the pyramids. We also have, in this case, Stonehenge. So again, in order to lift these heavy objects, the ancient civilizations would have used some simple machines to lift them. Now, the 6 different types of simple machines that we have are the lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. And what we're going to do is we're going to look at each one individually and just see different types of features. Some of these you've already heard about before. Some are pretty obvious what they are, although others are a bit more complicated. We'll also be doing some labs or simulations on the computer, which will help us to understand how they make work easier. Now, one thing machines cannot do is machines cannot increase the amount of work that you perform. I want you to think about the inclined plane lab that we did, where we had to lift the cart up the incline. And it didn't matter how steep the incline was, we always did the same amount of work. But it did make the work easier by reducing the amount of force necessary to lift the cart. There's actually 3 different ways a simple machine can make the work easier. We did a lab, that's a pulley lab, that helped us understand how a simple machine can make the work easier. One way it can make the work easier is that it can change the direction of the force. It is a lot of times easier to pull down than to pull up. For example, if you have to lift, let's say that you're going to place some shingles up on a roof, you need to replace the roof. And so now you got to get these shingles and all your materials from down here way up onto the roof. You could have one person stand here on the roof and pull them up, but that's a little dangerous and a little awkward and not easy to do. So a lot of times what we do is we might build a pulley, in which case a person can stand on the ground and lift by simply pulling down on the rope here. It's a lot safer and easier to pull down than to stand on the roof and pull up. Another thing that a simple machine can do is it can increase the amount of force. I cannot lift a car by myself, but with the aid of a jack, which is a type of lever, I can lift the car easily. So I can lift heavier objects, or I can increase my force if I use a simple machine. Another way that a simple machine can make the work easier is it can increase the distance moved. This would be like a catapult. So with a catapult, here we have the object that we're going to launch over here, and we want to fire it a long distance. And so what we do is we move this side here a short distance, and this goes a long distance then. Now there's always a trade-off though, and the trade-off is if we're going to increase the force, if we want to have a large amount of force then, and we're going to have to do it over a large distance as well. And here if we're going to increase the distance, we must apply a large force at this part in order to move the distance. So there's always that trade-off. If you want to get something out, you have to put something in. Now the first type of simple machine we're going to look at is the lever. A lever is a rigid bar that rotates about a fixed point called the fulcrum. There are 3 different types or classes of lever. And the class of a lever is determined by the location of the effort force, that's where we apply the force, and the load. Load is the object that we're lifting relative to that fulcrum. Now I want you to write all this down in your notes, and if at any time you have to pause in order to get all the information written down, please feel free to pause and then unpause the video once you're ready. Now, in a first class lever, the first type that we have, the fulcrum is located at the middle. It is located some point between the effort and the resistance. So the effort is where you are going to apply the force. And the resistance, that's called the load sometimes. That is the object that we are lifting. So here's where I would apply the force. The fulcrum, that's the part it rotates around, is in the middle. And the object that I'm lifting is on this end. An example would be a crowbar, because we're going to lift the nail on this end. The part it pivots around is in the middle. I'm going to apply a force on the other end. Pair of scissors. In a pair of scissors, you apply the force at the handle. The fulcrum's in the middle, and the part that's doing the cutting is over on the side. Same idea with the pliers. What I usually think with a first class lever is a seesaw. I apply a force on one end, the pivot is in the middle, the fulcrum's in the middle, and the object I'm lifting, my friend, is on the other end. In a second class lever, the load is located between the fulcrum and the effort force. So in a second class lever, the fulcrum is at one end, and I pull or push on the other end. The object I'm lifting is in the middle. An example would be a wheelbarrow. In a wheelbarrow, the wheel is the fulcrum. I apply a force here at the handles, and the object that I'm lifting, the dirt, or whatever's inside the wheelbarrow, is in the middle. A door is also a type of second class lever, where the hinges are on one end. I apply a force on the other end, and the object I'm moving, the door itself, is in the middle. Also a bottle opener. So again, it's pivoted around one end. I apply a force on the other. The object I'm moving, the cap, is in the middle. In a third class lever, again we have the fulcrum on one end, but now the load or resistance and the effort are switched. Now I apply a force in the middle, and the object I'm moving is on one end. An example would be tweezers. It is hinged at one end. I apply a force in the middle, and the object I'm moving is on the other end. Anything you swing, like a broom, a shovel, a baseball bat, is also considered a third class lever. Because I have it pivoted on one end, I apply a force in the middle, and it's going to move the dirt like for a broom on the other end. The next type of simple machine is a wheel and axle. It's pretty self-explanatory. The wheel and axle is a simple machine consisting of a large wheel rigidly secured to a smaller wheel or shaft called an axle. Example would be your car wheels. A screwdriver, I'm going to rotate the screwdriver. Okay, and it's going to be like the axle is the actual part here with the screw attached on one end, and then the wheel would be like the handle. Doorknob is the same idea. Next type of simple machine is a pulley. Pulley consists of a wheel, a grooved wheel that turns freely in a frame called a block. The block would be like right here, mounting bracket, the block. A rope or chain is wrapped around the wheel. Examples would be like a flagpole to raise the flag, the Venetian blinds, the window blinds to lift them up, and an elevator uses a pulley as well. Next type of simple machine is the inclined plane. This is an even sloped surface. The inclined plane makes it easier to move a weight from a lower to a higher elevation. An inclined plane is a stationary object, and you move something up that object. So an example would be a wheelchair ramp. So if this is a wheelchair ramp, you can move the wheelchair up to a higher elevation. A child slide, so we can go the opposite, from a high to a low spot. But notice that the slide doesn't move and the wheelchair ramp doesn't move. Or in terms of the hill doesn't move. They are stationary, and we move things up and down the inclined plane. Next is a wedge. Now a wedge looks just like an inclined plane, but the difference is Wedges are mobile. They are going to be moved. They are usually used for separating objects or for holding objects together. So to separate would be like the axe or the knife. They cut. So a wedge is something that can be moved, and it's used to cut something. Another example would be a doorstop. Like outside the classroom door, we put a wedge at the bottom of the door. It can be removed, it's movable, but it's used to hold things in place in this situation. The last type of simple machine is the screw. And a screw is really just a modification of the inclined plane. It is essentially an inclined plane wrapped around a post. That inclined plane goes around it, and that creates the threads of the screw. Besides, obviously, a screw being an example, another example would be a bolt, a spiral slide, like if you go to the playground and it wraps around or spirals down, or a bottle cap has a screw cap lid on top as well. So these are the 6 types of simple machines. And every machine, no matter how complex it is really just a combination of these placed together.